Hey guys, this is Austin Marquis teaching physics. Today we're going to do an experiment involving projectile motion. It's going to involve things moving in the x direction and things moving in the y direction. Now, what we've got here is this little contraption. Now, I'll try to explain how this works. Inside this, there's a spring, and it's connected to this little piston. Now, the piston actually goes all the way through, and you can see that it comes out on this other side. But as you move this spring across, you can end up putting it in one of these little notches here. It's actually kind of tough to do. Cool. Well, when you do that, it sticks out on the other side here. So you push it through, and then we're in there somewhere, right? Now, this is just so it connects to a ring stand. That's one of these. I'll show you that in a minute. But basically, here's how it's going to work. I've got these things, okay? The spheres. This is the box of spheres. Now we're going to take some of these, and we're going to put it on to our little contraption here. All right? So we're going to take one of these, and we're going to stick it here on the end. We're going to take another one, and we're going to put it there. Now, when I flip this switch, what will happen is it'll shoot. Now, it pulls this piston in really quick, allowing this ball to drop straight down, and it kicks this ball out. And we're going to watch them as they fall at the exact same time. The one that drops straight down, literally just falling straight down. And we're going to kick this one out to the right as it moves to the right and down. And I'm going to try to get it on film at the same time so we can see if one hits first or what happens. Now, we'll do this first with these two. They're really, really similar in mass. And I'll also show you that. So I kind of think you get the idea of what we're working on here. I'm going to try to find my way to get the best camera angle and make this happen and try to explain what is happening along the way. Alright guys, so to sort of show you the setup of what we're going to be doing here, I've got, you're connected to a camera. Yeah, that's all happening there. I'm going to show you a little bit of what's happening. So first off, we've got our ring stand here, and we're going to connect this on to the ring stand. Okay, we're going to slide it down. Pull that up. So now you can see this thing's going to be level, and it's going to shoot one out, and the other one's going to drop. Now, I'll do some tweaking on that, but I'm going to deal with these guys first. Now, to prove that they are relatively the same size, they're not exactly the same size, but they're pretty close. I've got a digital scale. So for our digital scale, I'm going to put one of these on there. And it says it is 22 grams. So this one is 22 grams. And it's over there. This other one here, we'll put it on. It is 24.2. So they're relatively the same. It's what I've got. So we're going to deal with it. Once we do an experiment using those, I'm going to do another one involving ones with different mass. So, yeah, that's sort of where we're at. All right. I'm going to go through, I'm going to get this thing set up, and I'm going to explain it a little bit further and see if I can't get this thing on camera. Okay, so I've got this thing set up. We are actually loaded. We're on the second notch in here. Hopefully you can see that. So then on the second notch, once I flip this notch forward, what's going to happen is this piston's going to move. It's going to shoot this way. This ball should drop straight down. This ball should be moving straight out to, that direction, whichever that is, left, right, I don't know. Depends which way you're facing it, I guess. I'm going to be back here. I'm going to flip the switch. We're going to see what happens. Hopefully you'll be able to see it all on camera. What I want you looking for Look to see if you can tell which one hits first. Does the one that's moving through the air hit first? Does the one that's dropping straight down hit first? Or do they hit at relatively the same time? That's sort of the thing we're looking at. That's the thing we're testing. And then we'll do it with masses that are different. Now, gotta hold this, be very careful. All right. Launch in 3, 2, 1. So those hit at relatively the same time. And any error that we probably had there was probably me tweaking, changing it. But as I hopefully you guys got to see, they hit relatively at the same time. The one that dropped straight down hit at the exact same time as the one that was moving out. That's because the X component and the Y components are not connected. The only thing they're connected on is through time. That means if you throw something at 90 degrees and it continues to move and fall, that if you drop something at the exact same time, they will hit at the exact same time on the ground. It doesn't matter that the one is moving in the X direction through the air. Those two things are separated. Now, we're going to try this a little bit different. What we're going to do is we're going to use, instead of the same two, we're going to use ones with different mass. Now, to prove that these are different mass, again, I've got my scale. I've got the first one that I used here, 22 grams. Now, we're going to use this guy. This is made of lead. This one is aluminum. This one is made of lead. Go away there. And we put the lead one on. 88.91 grams. Significantly bigger. So this lead one, this is going to be the one that the one that gets shot out. The heavy one's the one that's going to get shot out, and the aluminum one is the one that's going to fall straight down. We're going to see if maybe if they have different masses, what happens there. Okay, so once again, guys, I've got this thing set up. The aluminum one's going to drop straight down. The lead is going to shoot out to the right. I'm going to try to keep it as even as possible and not mess this up. All right. Launch number 2 with different masses in 3, 2, 1. All right, so hopefully that experiment shows us that well, first off, the X direction does not affect the Y direction. Those two things hit at relatively the same time, even when their masses are very, very different. I know you're not here to feel this, but one is significantly more mass than the other. The Y direction is what determines how long those things are in the air. They both have a change in Y direction, while one has also a change in X direction. That is not affected by the Y direction. It is only affected indirectly by the time. Okay? That sort of concludes this experiment, I guess. I mean, just as far as objects that are moving while through the air. So I will post other videos that do cover this concept, but yeah, that's what I got for you guys today. Thanks.